Welcome again, class number 14. I was just walking us through what the plan will be for the next coming weeks. So today is the 30th. So we're going to have 3 more classes to go. So we'll have one on the 6th, 7th, and then the 13th. The 13th is the one that we'll use to potentially run through our first major project. So I want to use this class to walk us through what the project will be. Hopefully, it's going to be a short class. And then we'll have the 14th off, and the following week, which will be 21st, all the way, we will be back. I think we'll be back on the 10th. So we're going to have 1 to 3 weeks off. We're going to be back on the 10th and 11th as normal. So we're going to have, start from the 14th. We're going to take this one off, 14th off, 28th off, 21st off, 27th off, 28th off, 3rd off, 4th off, then we're back on the 10th. But that's the plan. Hopefully that will be enough to catch up on whatever we may have been behind on, and obviously to run through the project as well. Cool. Right, to today's matter. So we're going to do a quick recap of where we are. And then what I have in mind today is to obviously continue with Jenkins and then spin up 1 or 2 machines with Terraform. We're going to add a little bit of more twist to our Terraform code, but more importantly, we will begin to lay programs and applications on the machines that we are setting up, just to kind of keep the theme of web, Python, Java, tier 2 system, keep the theme going. So just to kind of go back a little bit to where we were. So yesterday we made a big jump in our Jenkins journey. So on our Jenkins journey, essentially we looked at how we could save the S3, the remote state file, so the Terraform state file, where how we could actually save it on a remote system. In this case, we targeted an S3 bucket, which is somewhat centralized, and that allows us to access the bucket from wherever we may be running our Terraform code. What we had prior to that was a little bit limited in the sense that the state file was kept on a machine, which obviously had the constraint of access. So the S3 file can only be accessed by the machine where the file was created. But now we've kind of moved things to a more centralized location, in this case S3 bucket. And so it's easier to run the Terraform code from almost in any location, because the state file is something that can be almost globally accessed. So that removes the limitation of you have to run your Terraform code on 1 machine. And because the state file is centrally controlled now, we don't run the risk of inadvertently recreating new machines every now and again. We run the Terraform code, because the downside to losing a state file is your Terraform does not have a reference point. So you will assume whatever resources you're trying to create, that they are only being created from scratch, which sometimes might not be the case. The way we are writing our Terraform code is still very crude. We will over time perfect it 1 step at a time. And the array of resources that we are creating to Terraform will also naturally increase. Currently now, all we do is spin up EC2 machines. That would not be the way it would go for long. Things will change as we continue this journey, but I'm very, very deliberate in making sure that we don't rush things so that we don't lose our bearing, and then we can continue to build on the confidence we've had since the beginning of the program. The most important thing when one is taking this kind of classes is to make sure that the confidence remains intact, even if it comes at the cost of not really speeding up the classes, or rather you guys understand it than me rushing through things. All right, cool. So what we've had we have our, if you like, our tool server, which is running Jenkins. With Jenkins, we said that we are able to use that as a CICD or like an automation medium that allows us to execute command. In some cases, Terraform command, in some cases, Packer command, in some cases, just plain old shell command. But whatever you want to do, Jenkins is just your tool that allows you to do that. We also said that Jenkins doesn't really have a brain. Whatever you want to do, you have to, be very explicit with Jenkins because on its own it doesn't do anything. You have to explain what you want to do to it. So it's not like the most intelligent tool out there. It is just a tool that allows you to put things together and kind of run it. Maybe remotely, maybe locally, but allow you to pipeline your work, pipeline your code, pipeline your workload, whatever it is. But it's not like it's the most intelligent tool. So you always have to be clear what you want to do and have the necessary tools um, already configured to do the work. For example, Jenkins on its own cannot run Terraform. You have to have the Terraform binary on your system. It could have an agent that allows it to easily work with the binary, but the binary itself has to be installed, which we have seen and we have practiced in our previous projects. So also when we're looking at the just shows the project we've been playing with over the last few weeks, which is the fruit vegetable market project, which is this one. Obviously on here, we've said that we need a tier one system in this case, which is our web server. We have the option of using Apache web server, Nginx, and what have you. And then targeting the tier two system, which in this case is the Python and the Java system. So we also said that what makes a system is not just the VM. In this case, obviously, we are looking at an infrastructure as a service setup you can reform. And on this, you have to deal with the hassle of putting whatever application you need on the VM. So because you are using the IaaS approach, infrastructure as a service approach, you would have to take care of the business, not least obviously preparing the VM, as well as also installing the right software on the VMs and also preparing the VMs. So the first task will be obviously spinning up the VM, which Terraform helps with. And then the second task will be laying the applications and configurations on the machine that turns it from an ordinary VM to like a web server, app server, or database server. So the application you run on the machine makes it what it is. So every machine is just a humble VM at the point, just like a baby. Nobody is born like, super intelligent. Everybody's sort of born equal. And then over time, you accrue knowledge based on your family background, the money you have, exposure, and then you become a different person. The machines are all the same in a sense at the start. And then whatever you put on it then makes it to become a database machine, a web server, an app server, and what have you. So we're going to be getting to change the nature of this machine. So we're going to look at how we use Terraform to prepare the machine one more time. So this is the app side of things, if you like. This is when we turn the machine into web server or app server. The code we're using to prepare the system is still very humble. We're going to kind of make it a little bit better today. So we look at what we have here, which is this is where we have the Terraform code, which is creating the VMs. We also looked at how we could use Packer to prepare the AMI, which a lot of people have done some good work on, which is brilliant. So we're going to look at how we can extend this a little bit today, right? To begin to prepare system as web server, app server, and begin to add little tweaks here and there. I'm always gonna try to create some gaps so that you can fill in those gaps when you do your weekly projects. I'm not gonna do everything, but I'm gonna do some things, explain what needs to be done next, and I will put that as the project work for the week so we can have something to put our teeth into. So we look at this, for example, this is we're able to extend the code a little bit. You can see it's kind of gathering momentum. Our code is beginning to look a little bit professional. It's still not very professional yet. There's certain things we can hide here in terms of how we control locking on the Terraform state file. There's a way you manage locking, which I will explain at some point in future. So you can introduce something like DynamoDB to manage logs. I won't talk about that today, but it's something that we will include at some point in future. It's a little bit advanced, but we'll talk about it. So that was the main thing we added yesterday. The other thing we added was putting this as a Jenkins pipeline system, so that we no longer have to put the pipeline in on the Jenkins machine itself, or we can run it external to Jenkins by preparing a pipeline file that we then reference within Jenkins. And I also mentioned that you could do one for Packer as well, where you do your Packer code and then you reference as a separate pipeline. And the reason why we're using different file names is because we want to keep everything in one repository. If Packer and Terraform were in different repository, then you wouldn't really need to change the name. But we all started with this. And then we said that if we use a Jenkins file, which is like a default file Jenkins looks for, then we are going to have a problem automating Packer pipelines and Terraform pipelines, because we don't want to model everything up in one single pipeline. So we then say, okay, we are going to do it with the Jenkins file, but we'll use Jenkins Packer for Packer, Jenkins Terraform for Terraform. And that's what we've done. Okay. So this is where we were. Okay. And so this is where we're going to take things out. So what I have in mind today is to we're going to spin up one machine, just spin up two machines. We're going to begin to configure port using Terraform. I am not, we will begin to prepare machines as web server. We can begin to prepare machines as Python server, and then Java. So I probably will leave Java out so that you guys can play with that as the big project. So potentially let's do two systems. So let's make this blue. So these are the things we will target today. So we don't have much ado, let's do. So we'll prepare the system first. We look at them, and then we'll begin to do pipeline that will then begin to install and configure things in there. And I want to kind of take it stepwise to see how we would achieve that in a very comprehensive way. The approach is not going to be the most it's not going to be the most the best approach, but will be adequate and will be easy to explain. And when we get that, then we can build on that to do it in a much more better way. Okay, so let's get to it. So this is our Jenkins system, right? So we have this pipeline which we created yesterday. We go configure, and this is referencing our Jenkins machine. Sorry, it was referencing our Terraform code. So if we go here, that's the one it's referencing, which is obviously this one. And let's put them next to each other so we are not going back and forth. Okay, so the Jenkins stuff is referencing that main branch, which is the branch main branch here. So the repo, the branch, and then we are targeting the Jenkins Terraform file. Jenkins, this is where all the instruction is for the Jenkins system to do what it has to do. So in here, we are defining parameters. So if you want to do Terraform plan, sometimes you want to do just apply, sometimes you want to destroy the machine. Also, we have the credentials, so we can look them up in Jenkins. We've set them up as normal. We check out the code, then that gives us access to the Terraform code. We do the init, we do the validate, depending on what we select as the plan, then that gets executed. So obviously, everything still comes down to the Terraform code itself, and the code is still very, very crude at the moment. So we are only just creating one single system called Nginx node. So we're going to change things a little bit. So one step at a time. So what I'm going to do is I'm going to check out this code, and I'm going to begin to attack it on my machine. So we're going to prepare some things and then extend this code to be so that it covers two machines. So we do web, maybe web opens port 22 and port 80, Python open port 22 and maybe port 9000. So that's going to be the first objective. So let's get to that. So updating the Terraform code and then taking care of business to help us create those two machines. So I'm going to check this out. Again, if you're checking out and you want to update, it's good to use the SSH one. So copy that. And I'm going to find a good place to do my terminal. There we go. I see. Okay, I've got one here. So this is my local machine. I want to pull the code down. I'm gonna go to temp. I'm just gonna make a directory. I'm gonna call it. I'm gonna call this class 14. Let me go there. It's 14. And then I'm gonna pull the code down into class 14. It gets clone. I'll pull it down here. And I'm gonna go in there. And I'm gonna open the studio code here. Okay. I have not set up my class environment. Let me do that real quick. Hey, let me give you one more go. It's that. Okay, that's worked now. Fantastic. Okay, cool. Where is it? It's hiding. Find it. Okay, it's hiding just there. Okay, and let's put it there, right there. Cool. Okay, so this is it. Let's close all this noise. Have that. Okay, that's it there. And then let's have access to the timeline here in case we want to do stuff. So this is what it looks like. So we go here, we look at the main file. This is what we want to attack. So this is currently where things stand. We only kind of, bear with me. We're only kind of creating two systems right now. So we're going to extend this a little bit now to hopefully take care of business. I want to kind of make it more of like a democracy, if you like. So we're going to build it together. I haven't really prepared anything, so we might run into certain troubles, and I will show us how we deal with this and how we can get quicker. By the way, when we come back next year, I'm going to show us how to use AI to do this way better. But if we start with that, we're going to lose the raw knowledge we need to understand Terraform. There's an easier way of doing this, leveraging LLM. But if we start with that, it will do us a disservice and we might struggle passing interviews. So I wanted us to kind of understand the concepts first before we then begin to take the easier approach, because it's a lot easier to do these things now than it was 24 months ago. We are going to at the point switch to using LLM to write our Terraform code, which makes it a lot more easier. But we won't start with that just yet. So let's continue to kind of take the hard approach so that we can use that to help our learning. So the thing we want to do now, obviously, is begin to create things the proper way. Okay, create things the proper way. So, for example, we had just one machine here, which with our Nginx node, we didn't name it correctly. We probably, Nginx node is fine. So probably we'll call it the web node. Then we're going to create the correct security group it needs to do what it needs to do. And then we will not be relying on security group that we created externally. Somebody asked me this question. I think it was Wale. Wale, that question will be answered today. So we are going to extend it, but we will not do too much on this because I think at 9 o'clock, 10 o'clock Nigerian time, I want to switch to how we begin to lay applications on the machine. So
you'll need to unlock your iPhone first.
Okay, this is Siri is dropping on me. Okay, cool. So let's do the security group. So we have this. So we are going to let's create a security group. Let's just call this. So we're gonna say, and just put some comment. It's always good to comment these things. I would say, let's say web node security group is the okay. Do that, and then we start. Okay, all right. So that's the first thing we do. And then we begin to actually define it. So there's a resource called security group resource. AWS security group, AWS security group, GROUP. Again, okay, let me do this first and I'll explain something to us real quick. Nginx, or let's say web SG, something like that. SG. We're gonna deal with this later. So one thing I need to show you is Terraform has like it has like a help page that you can go to see how you lay this out. So if you have a resource that you want to work on, for example, in the security group, and you don't know how to do it, you can copy this and go to the registry Terraform page, which is here. And then you can look at things there. So any resource you want, in this case, just security group, you will then see what is important, examples, which you can leverage and just play with it. So you will not be starting from scratch. You will just be basically leveraging probably what is there. So in this case, for example, this is a security group that allows you to, you access a VPC ID, and then you can lay out your security group. That's not the one we need. What we need is the one that allows us to do egress and ingress. I'm looking for a complete example if I can find one here. Okay, sometimes you don't, and you have to kind of fly blind. Okay. It says somewhat close, but I don't like this security group. Allow TLS. Okay, there's no really standout example here. So we're just gonna go. So this is kind of okay, but it still doesn't. I want to do ingress and egress. Anyways, this gives us an idea of what we want to do. I was hoping we'll find one that basically defines everything very well, but I don't really like that. So okay, let's fly blind. Okay. So what we want to do first and foremost is in our security group, we're going to give it a name. That will be the name that will be on when it's created, the name that will be on the cloud platform. So we kind of let's call it web security group. And then we give it description. Let's call it allow SSH and port 80 inbound, something like that, or outbound, something like that. Okay, so that's what the description is. And then we need to attach the security group to a VPC ID. So we need to find a VPC ID, which will be our main network ID. I don't know what that is. We're going to look that up later. Okay. And then we'll begin to define the incoming traffic, which will be inbound. So let me just make a comment inbound. And then we'll have ingress. This is coming in. We begin to define that. So we define description. This will be for SSH. Okay, and then we'll say from port. And then we want port 22. And then 2 ports. And that'll be 22. And then protocol. So we want to use the TCP protocol. TCP. And then who is able to do this? CIDR log. It's going to say anyone should be able to access these CIDR blocks. Good news, we're going to be looking at networking next weekend. So everything is going to be blown out of water. You're going to be able to understand all the 0, whatever better next week. So this will change next week and we'll see what this means and a bit of networking knowledge. So that's the first inbound. This defines the access to port 22. Obviously, we want port 22 and port 80. So kind of we can copy this again and replicate for port 80. Say maybe inbound. I said maybe this is inbound SSH. Like putting comments on things, it just makes it easy to follow. This is inbound web 80. I just say web. But then this just changes basically. So let's say web port 80, something like that. And this obviously then becomes 80, 80. And then protocol is just let's allow anything protocol. So it can be TCP, UDP, whatever. So the options here is they can have TCP, UDP. If you put _ means anything. And then sorry, this should be TCP rather actually. So this shouldn't be anything. Yeah, because we want to just make limited to TCP IP. And then we'll say CIDR block anyone. So only allow TCP access to this port, allow anyone to access the port, and that will be the whatever traffic that is going to be coming in. So if we go to that little diagram, we are saying if we set this up as the web, which would be this one here on the kind of the traffic flow, but if you look at it here, so we want to allow inbound who's able to access it. So let's say there's a little guy here who wants to access this machine over the internet. Okay, so you'll be able to use, you will be able to use SSH protocol as well as spell it out. As well as 80, which would be HTTP protocol. Okay. HTTP protocol runs on port 80 by default. HTTPS protocol runs on port 443 by default. These are the default, but SSH runs on port 22 by default. By default means that is what is expected. You can change it, but that is what is expected. Sort of like the normal standard. To go back to the little code. So this is inbound. So this means traffic can come in, but can traffic, so when you send message to somebody, you have to send your response back, right? So you have to allow the response to go back to if somebody trying to access the system must be able to respond back to the person. So you need to set up egress. Okay, traffic should be able to go back. So somebody's sending SSH connect, then the system should be able to respond to the person. Otherwise, the system just hangs. It's taking information, but it's not sending anything back. So you need to define egress. So what's able to go out? We are controlling what is coming in. There's no point locking down egress. For one main reason is that when system is communicating back to somebody sending a response sometime, a system might choose the port is using to do response communication. What that means is incoming traffic might be coming on port 80, the system might be responding on a different port. So you generally won't know the port the system you're going to use to respond. That is why usually egress is open to all. So you don't really block egress because you don't know the port the system might use in responding back. And that is why usually you will see egress basically created to be a little bit more freer than ingress. So the system can choose how to respond or the kind of response or inflow or inbound traffic that system takes. You should be locking that down and be more aggressive with that and let egress kind of flow as normal. So what we are saying here is we are not really blocking egress. The system can go out send response back, but we are blocking what traffic can come into the system. So the egress is, so we're just gonna say here, so just say allow all outbound traffic, something like that. Okay, this is what we are saying here. Okay, and then so this is then defines the security group that we would attach to our EC2 machine. So we're just gonna create one. So we probably just create a tag for it. Let's just tag it, tags. It's always good to do this. So we're gonna tag it, we're gonna give it a name. Call it web security group, That's what we're gonna call it. So we created a tag for it. You can have as many tags as you want, but let's keep it nice and simple now. We have not filled this. I haven't forgotten that. So we are going to then, we're going to find the VPC ID. Okay. Do we have the VPC ID? Okay. I'm going to look up the VPC ID later. We'll attach it. So we are no longer using the security group that we manually created. We will attach the right security group to it. So we're going to extend this now. So we would just call this, let's call it, put some comments, make it nice and beautiful. Just call it EC2 instances. Okay, and then we'll kind of look it down that way. Nice and beautiful. And then what we do is we then begin to change this a little bit. We can use EC2 instance. Let's call it the web node. And then, yeah, we can use the 3 micro. We can keep this. Obviously, if you don't use Parker, so you reference your Parker AMI here if you want. The subnet, I'm going to leave the subnet as well. Next week, we're going to be creating network ourselves. All this subnets and whatnot will change as well. Now, this is a big one. So this changes. So we're no longer looking up security group from the system that we manually created. So we will not be using manual approach for security group. Rather, we will reference this one we just created, which is this one. So literally, we'll just take this. Okay, we'll copy that, copy. Then we just reference it here. So we just go here. And it's very easy to reference it. So you just say that is the resource group name. That's the name we've given it ourselves. We call it SVWG. And then one reference just the ID as an ID. The ID then comes here. And that's all we need to do. So that then defines our system. Obviously, we still don't have, I haven't put the security group ID there, so we're going to put that very shortly. So this still kind of remains the same. Let's just call it web node. Let's keep it nice and simple. Let's call it web node. And that's it really. So that's the little change we need to make. I'm going to look up the VPC ID now, and then that should conclude the web creation. So if we look at the ones we've created prior, let's look for VPC ID. That's our VPC ID. We copy that. We bring that here. Again, see network creation. It's going to be something we look at next week. It's going to be good fun. And at that point, we will no longer be looking up subnet and network information. We'll be creating that as part of our pipeline, as part of our Terraform build. So we come here. Where is it? It's hiding. Yep, just right there. And Bob is your uncle, and that's all we need to do. So this is all kind of done-ish. So what I would do, this is on this machine. So where are we? This is my local machine. And we are in this folder. So I'm going to just step into Terraform, which is this file here. Is this file here. So I'm just going to do Terraform validate. Let's see. Okay, so I need to do init. Init takes forever. So while this is waiting, because it's going, it needs to install the the plugins, it sometimes takes a while. I'm just going to use that to run everything. So this will, okay. All right. Forbidden. Oh, because I have not done my export. So here it's saying I can't access the bucket because that's where the state file is kept, remember, which is this one. For you to access it in the security information, which I have not provided. So I'm going to do my export. The other exports as well. And the last one, exports, export, 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 export. That's one. Okay, so this should be good now. Let's clear the screen. And then I can do init now. And then let's see. So it looks good now. And that's fine. We're gonna take some time. Let's bring that up. So while that is cooking. So obviously when that is ready, we're gonna push it and we'll update this code base. I haven't pushed here, so this will change. Right? And when that changes, so I want to then I will basically bear with me. So when that updates, when we push it, then we will then go to the pipeline to then tell Jenkins to execute that for us so that we can have those systems provisioned here. So that will then create one machine for us, and that will then move to creating the other machine, which will be the Python node. Okay, cool. Right. So, okay, this is all done now. Right. So I can then do validation before I push the code out because I don't want to run the code locally. I could do it, but we're discouraging that I want to use pipeline for everything. So I can, before I push my code, I want to make sure it's valid. So that means I want to validate it. So I don't want to have any syntax problem. So this is just checking it to make sure it's good. So it's basically checking it. Okay, so it's good. I'm just going to format it now. So to make it nice and beautiful. So because I may not have respected all those, the formatting is not really, there's not much to it, but it's always good to do Terraform format. So it can help you put your code together in a much more less tidy with FMT format. Okay, now it's basically just arranged it so align the equal to, it makes it just beautiful. See, I like that a lot. And then I think this is good to go now. So we would then do, let's check the pipeline to make sure we don't have anything that we want to update that is missing. Yeah, this should be all right. Okay, I don't know what this is. Okay, console terminal. Okay, cool. And then we can, let me clear that. So we then do git. So we're in this location. Let's move back one step and then we'll do git status. See what's changed. Okay, we expect just one file to change. That's excellent. So we can say git commit, or we can just do here. And then we can say commit. We can say updated Terraform node to create web machine with ports 80 and 22. Okay. Yeah. You can commit and push. That's the plan. Okay, and then hopefully I put something there. So, okay, that should have updated this file. There's something in, okay, let's see. And then I'm going to talk about one thing real quick. Yeah, this is changed now, as expected. When we move to pipeline much later, so we're going to see how, just simple commit can auto trigger the pipeline. So you don't have to run the pipeline. The pipeline just run by itself when there's a new update in your repo. We're not there yet, but we get to that point. Also, We will not do too much again on Jenkins going forward. This is going to be one of those last classes on Jenkins because we're going to move to Git action and we'll continue to extend the project, but now with a different pipeline. That just helps us to learn Git action, which is another popular pipeline tool apart from Jenkins. As I said to you, that sort of a plethora of pipeline systems, Jenkins, GitLab, Azure DevOps, Azure Pipeline, if you like, AWS Code Deploy, uh, GitLab, Bamboo, Git Action. There's a lot and lot and lot and lot of. So if we can learn two and know those two well, then that we would gonna serve us in good stead. So we have this obviously code written now, and then we can go to so we can then go to a pipeline and then attempt to execute it. So this thing still remains the same. Obviously, the code is accessing has changed. So we're just gonna go to pipeline and then build with parameters. Let's do a plan first to see what it's gonna look like, and then we can run build later. So hopefully the plan should be good. So we can have a look and look at the pipeline overview, see what it's up to. It's doing init, which we probably take some time as well. And then we do validate with kind of we don't expect any issues here because we've done this on our machines anyway. We've done init validate, so we do that as well. And then the plan is going to be the biggie to see if there's going to be any serious issues for us. Okay, the plan looks good. So let's look at what it's going to do. So it's going to be creating a machine for us because I deleted the machine that we created yesterday. So, and it's going to create a security group for us. So when all is said and done, what we'd expect is the new machine here, we'll call it's going to be called the web node, something like that. And we would expect a new security group here, which is going to be called web security group, something like that. Everything is launch wizard launcher. We should have a new one that bears that name. Where is it? It will be called WebSG, which is what we create as a tag, yeah, web security group, something like that. So two resources, one security group, and one EC2 machine. So there we go. So we go back and then build with parameters again. But in this case, we're not doing a plan now. We're going to apply and then hopefully it goes well. And then we have this machine set up. We can continue to check it out. So the auto approve is on now. So while that is going on, okay, this is all good now. So it's all created. So let's go check it out. So if we just refresh this now, we have a new guy here. Voila, we have the web node. And also not only that, we got the security group. We should have one called web something something, WebSG, which is the one is reflecting our license component, blah, 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 blah. The description. This is what we have now. And then we can just test that out real quick. And then we'll speed things up a little because we have a template now. So if we look at instance EC2, we should be able to access it. Obviously, there's nothing running on it. So if we go like dashboard, on instances, and we just check that and then connect to it. Just make sure those ports we hope are open, actually open. Yeah, it's good. So date, uptime, uptime. How long have you been running? minutes. Okay, that's expected. Fantastic. So we have a very viable system, right? If you go back to our little diagram, so this is all chinking, kiching. This is good. Obviously, there's nothing running on it, but this is our potential web node. So let's prepare our potential Python node as well. So it's going to be the same thing. And don't forget, the approach we are taking is still very crude. And let me point something out here to just to reinforce that. Okay, right. So if you were doing this properly professional way, we're not going to be hard coding values here. We're going to separate the values we are putting here in what we call a variable file. And then we can have a clean code that doesn't reference any number. This will probably won't make sense to a lot of people now. But at some point, all this we're going to do it with them. We're not going to be putting values here, but we're going to be putting variables here. The reason for that is it allows you to create a code that a lot of people can use. For example, if I give this code to Wale now, it won't work for Wale because Wale probably doesn't have a VPC that has this number. It probably doesn't have a system that has key name of this, or maybe a subnet of this. So this is specific to me. So that is not the way you write software. You write your software such that anyone can use it. So the way you write this is it will be not opinionated. It will not be biased towards me. You would use variables here so that when anybody that wants to run it will create his own variable file. It will say his key name is Wale's key. His instance ID is something, something. And then you bring your variable file and then you will run it together with a code that is not referencing direct variables, or instead using variable name. So that's the best way. And we're not there yet, but that's where we're gonna get to. And that's the professional way of writing code. And also it's not good to do repetition. We're gonna be doing a lot of repetitions here. That's the second point. The third point is most of these things are commonly done. So people do this EC2 creation, what's it called? Security group creation, EC2 creation a lot. So there are actually standard modules that people have created that super simplifies this. That we actually don't need to do this much, but we should be using module that other people have written and leveraging it and making our work super easy rather than trying to be heroes and doing things from scratch. This is the hardest way you can ever write Terraform. So it's a lot more easier than this, but we're going to get to that point. For example, creating instances should not be something we do like in a plain naked form like this. We probably should be using modules that allows you to just specify a name and then boom, 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 you create it for. We'll get to that point here. That's later. Our Terraform journey is going to be a long one, so we're going to keep adding to it every week. So now let's extend our code a little bit further. So we're going to do the other. Right. So let me just close this bottom one for now. Right. So we have the security web node security group and instance. Let's just call this web instance. Because now I'm going to just basically copy this. So I can create I can create the one for the Python code, which is this one. So again, this is not the best approach, or it will be only kind of logical in terms of how we're going through our journey. So I'm going to create a Python one now. So the Python will probably open port 9000, whatever port you choose for your Python code. So that's not going to be the port we'll create. And then, so I'm going to copy all that. And then I'm just going to put it at the bottom here. So then I'm going to begin to make adjustments. So everything kind of starts here. So which would be, so we're going to call it the Python backend setup. Okay, so let's call it that. So this will become Python SG. Let's call it Python SG, Python SG. So our port is in port 9000, whatever port you choose. And then the VPC ID still remains the same. Inbound is the same. This is going to be 9,000. Let's call it app. And then 80. This will be a port. Python port 9,000. 9,000. 9,000. So egress is fine. So we call it Python security group. Okay. Set. So Python SG, and then Python instance. So we just call it Python node. Python node. And then this would be this name here. Python SG. You can refer Python SG. Okay. I didn't copy so well. Copy. And then bring it here. And then that's it. And then we call it Python node. Python node. Okay. One thing I also want to do is when a machine is created, I want the system to output its name, so I won't have to come and look it up. So when this machine is created, I always have to come here to check it out. I don't want to be doing that. I want to check in my pipeline. I want my pipeline to tell me what the name is in the pipeline here when it's created. I want it to kind of echo the name out. So I'm going to define my output parameter, what I want the system to show me when it's done. So I'm going to define my output parameter, my output information. So when you've created this thing, I want you to tell me a few things, and you can define those outputs. So outputs. So what I want is, I want the public IP or the public external name, public external. Let's do it that way. External public external IP or public external names. Let's do the IPs. The public IPs, I want to know. And keep it nice. Keep it nice. Okay, keep it nice. Okay, cool. Right. So here I'm gonna say outputs. So I'm gonna say this should be the web node. Web node, let's call it web node and web node IP. So we're gonna define that here. And then let's see. The web node IP. So what we want to do is description, public IP, public IP. And then the value, what should it actually do? So we want to export this value. So it will be, so what we want to do is we want to expose this name of the web node when it's done. So obviously, so we go here, this is the web node. So we access this machine that is created here. So the machine is, which is the resource is the machine. The web node is the name, and then dots is public underscore IP. So literally this. And then we'll come here. So we'll take all this out. Let's do dot is public IP. So and then we'll bring all this stuff. So that's what it's gonna output. So if everything goes well, it should tell us what the public IP address is. Okay, and then so that will be That will be web node IP, and then we'll do the Python node IP as well. So let's call it Python node IP, public IP, and let's look at what the name is here. Where is it? Okay, cool. And that one. Just call it Python node. And then that will just be, just that. Python. Python. That's it. So this looks cool. Let's check it out. Usually we just do, let me go in Terraform. Let me clear screen. Let me make this a little bit bigger. And then CD Terraform, where we are. And then let's do validate. Let's check it out. Okay, good. So status. Okay, and then we do a get commits. You can do it here. You can do it here. But let's kind of swap it, sometimes do it here for people that want to click. People that like writing command, that like I do, you can do it here as well. Commit AM, say added code to create Python node, something like that. And then git push. And this goes, and that should update this chap here. So invariably it's going to get longer. Okay, fantastic. Welcome. And then we have another beautiful go. So we go here again, and then another go. Build with parameters. Let's kind of speed things up now. We're not going to do a plan. We're just going to take the plunge, and boom. So this would get us to moving these up as the second node that's being created. Okay, get a bit overconfident that things will go well, so we never know. So blah 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 blah. Okay, here it's doing all the good work. It's doing all the good work. Okay, blah blah. I think it's gonna go well. So if it goes well, it should. Okay, it's gone well. So if you come here at the bottom, you see some beautiful names here. There you go. That's what we want to see. Python node, the web node. So these are the names here, and then we're good. Okay, all right. Let me check something. Okay, cool. Yeah, we're good. So that helps us to just because in reality, if you're working for a big companies, you might not have access to console. It's not every time you go to console and have a look at stuff. So you can do all your beautiful stuff just within pipeline. You have your name, you have your IP. You don't really need anything. You don't need to see the console because you have the IP address to accessible to you, and then you can play with. Okay, cool. I mean, I'm just outputting just be a public IP address here. You can literally output anything you want. Those names of the information you need, they are here anyways. So you can just get it after it's been created and just access it. Just say public IP, you can do public DNS, you can do private IP, whatever you need. Just grab it and then just add it to your code because it will not make it known. And then you can just say, I want it known. And you add it to your code here, whatever else you want to be outputted to you. Okay. All right. So now we have those two machines. Fantastic. Okay, now this is not there yet. So the web node, okay, I'm going to play with. So these are the ones we created, right? So what we want to do now is we want to begin to prepare the system as a web machine and as another one as Python machine. So on the web machine, what do we need? If we go by the little diagram we have, which is here. We go classic. It's not where we want to go. We want to go here. And we want to access Reapers and the fruit bench market. So the web machine should basically run, in our case, Nginx, and also should deploy this Nginx file. And then everything that it needs to do has been, I think, has been called out in the README file. So on the web, on the machines, the one that is called the web node, okay, the front end should install Nginx. So install Nginx on the machine, install Git to download the repo. Okay, so those are the things we need to do to prepare the system. So we will need to download this repo, but we need to install Nginx as well. So if we had a system and wanted to prepare that system as a web node, so let's refresh this. Okay, so this is throwaway system. Don't worry about this to delete. But we have the Jenkins file, which is our tool server, the Python node, and the web node. We want to begin to prepare this web node as our web machine node. So, the documentation says you should install Nginx on it and Git on it as the web node. Okay, to do that, we want to do that using Jenkins, remember? So essentially, this has to run remotely on the machine. So we know the command we need to use to basically run to install Git and Nginx on the machine. So we know it's going to be yum, whatever it is. But if you're using like Ubuntu Linux, you have to use apt-get or app install, whatever. So you have to have the command handy. So what I want to do to simplify this is we can do a little script. So we can check in the script. What do I mean? So I don't want to touch the system here. So let's use this system as a throwaway. Actually, let me spin up the system so we can kind of collect the command we need to prepare system as awareness, because I don't want to touch this. So I want to kind of gather all the commands we're going to need. So let's launch a system. Let's say we're just going to assume we want to prepare a system as a, let's call it throw away. Throw away. Throw away. I'm going to call it that. And then we will just set it up as normal. So this will just help us to prepare all the things we need. So we'll launch. So I want to use this to collect the things we're going to have to do to prepare a system as a website. In your case, this might not be necessary, especially if you use Packer to prepare your AMI. You would have everything you need. So you probably will not be needing to do Git install this Git install. So it depends on the approach you want to take. You want to take the Packer approach to prepare the system and you have the right AMI, which you can then leverage. That would make sense to people that worked on Packer. But if you don't, you might need to add some little extra steps. But anyway, we want to use this machine to kind of prepare what we're going to have to do to get the system ready as a web server or as a Python application. Okay. So if this was our web server, we're going to need to install Git. We don't have Git. We don't have sudo systemctl systemctl status nginx. We know we don't have it. Okay, so we would then do sudo yum install git -y. That's what we're gonna do. Okay, and then we also would probably do sudo yum install nginx -y. Okay, that will install the two things we want to do, and then if those two have been installed, the next thing we're gonna do, I'm gonna do them. I'm just kind of preparing us, be ready. Then what I want to do is I want to find myself in this home directory. So I will say CD to home directory so that I will find myself here after doing the installation because I want to land here. So let's say the system has moved away to maybe temp or whatever it may have moved on to. If you CD tilde, it brings you home. This is your home local directory. So I want to be home. Why do I want to be home? I want to be home because I want to pull down this repo and I want to put it down in home directory. So I'll first of all CD tilde, and then I will use HTTP to download. I'm using HTTP because I am going to be on a machine that doesn't have SSH key to this repo. So I have to use the HTTPS instead of SSH. So I use HTTPS to do the code download. So what do I mean? So if I come here, I would then do git clone, and then I will clone the repo here. So I'm going to do just this one, and I'm going to show something. So let's say you clone, right? And this clones, okay, we don't have git yet. Okay, cool. Right. So let's install git and let's clone. So let me show you what I mean. So what I'm trying to do is I'm trying to build all the commands we're going to need to do this well. So we're going to have to install git, we're going to have to install nginx, and we're going to have to do a clone. And then we'll see the problem we run with, which might potentially running when we do a clone. So I'm preparing this command because I want to write a script that does everything. So I'm going to prepare this, use this command to install git, is it to install nginx, and then go to home directory so that I make sure I land in home directory, and I'm going to then do a clone. Okay. So I'm going to write I'm going to put all this in a little file, and I'm going to call it install script. Install script .sh. That's going to be the file. So I can actually create that file here. So we'll play with it. Okay, let me even do it here. So we can just harvest this command. So the first command is that. So let's do it. Actually, this is the first command. So I'm going to I'll create the file called install script. I'll put this here. Okay. Okay. And then the other thing is sudo install. It's actually probably I'll take the git out at a point. So very good. Install nginx -y. Okay. Think, and then let's leave it at this two for now. So this will change as we kind of go along. So I'm only preparing a script to do this. So the reason I'm doing this, remember, I'm playing on it. I'm putting this together on a throwaway file on a throwaway machine because we're going to have this command, and that is what's going to help us as the basis to automate what we need to do on a machine. So what I'm doing that might not really make sense. It's just me collecting the command I need to that we use to prepare a system as a web machine or a Java machine. I know what I'm going to do, but I'm kind of just showing you my thought process. So somebody's asking a question. Do we need to put, yes, we do need. Yes, that's a great question. So they're saying, do we need to put beam bash? Yes, we do need, but I didn't want to start with that yet, and so that people will kind of follow. So what Terraform is saying is that we need to put a shebang on top here to kind of signify this as a bash script. Yes, we do. Okay, so that's my question. Okay, cool. All right. So if you don't put anything here, you can actually run it. Okay. And it still would work. So this is the script file. Remember, this is a throwaway system. I can just run the script and say sh -x. So as executes this file, I will say install script, and then it will run. Okay. Remember, this is a throwaway machine. We're going to delete this machine. We're just using it to kind of put together the command we're going to need to do our work. Okay, so that works. So if we the reason why so I've executed the script using this, and that would have prepared my Git. As for me, I will still come back to the shebang stuff. So I'll want to talk about. So, but this has given us Git, which we have installed now, and has given us Nginx, which is installed but it's not running. Okay, it's there. So we can update the script also and say the install script. We can say if Nginx is installed, we can do sudo system control Nginx and Nginx Nginx start, and that should start Nginx for us. So if we run the script again, and then I'll start Nginx Nginx.service, I think. Okay, command of oh, sorry, start Nginx rather than Nginx start. Okay, and so I'm putting all the commands together. Okay, so Nginx would have started, this would have started Nginx if you then do status. So now it's running, it's good. Now, but you notice that anytime I want to run my execute command, I'm putting sh minus x on top. If you don't want to be doing that, if you just want to run the script without putting anything in front, which is the sh, which is sh execute, you can actually do that here and tell the operating system that this is a bash script. So you won't have to put any sh minus x in front to execute. To do that, you just put a shebang message. Okay. Then you say system, take this as a bash script. That's what you're saying here. If there's a Python script, you say system, take this as a Python script. In this case, a bash script. So if you do that, and you make this an executable, so you say minus x install, make it an executable. Then going forward, you won't have to put anything on top in front. You just work. But if you don't want to go through that hassle, you can always do sh minus x, sh minus x. So this is just by the way. So the main thing is the script we are preparing, right? So this script would install Nginx and whatnot. This would change naturally. I'm going to change this. Bear with me. But I want us to kind of follow my thought process. So we install with all the things we need, and then we'll do a clone of the repo. So I say we want to find ourselves in the home directory. Okay. So, and then, where is it? So we then update the scripts to find ourselves in home directory. So what we'll do is we'll say cd home directory, and in there we'll do git clone that. I think it's .git. That's the one we need to clone. And then we can then obviously then basically after we clone, then we'll copy the file, where is the file for the web one? We will copy this web file, index file, which is going to be in web folder. We're going to copy it into USR, share USR share engineer HTML directory. We've done this before. And then that's what we're going to do. So if we go here, after cloning, we will cd to this directory, which will have been created. So let's do that first so that I'm not jumping. I know what we have to do, but I think it makes sense. We'll do it together so you understand how to write a script. That's not really difficult. It's just put it together what we have to do. So we're going to run this again, and you're going to see the problem we're going to run into if you run it many times. So this runs, and then we'll download the code, blah, blah, blah. And then in here, we should have that code downloaded. Okay, if I run this again, it's going to fail. Okay, because it's saying the destination already exists. So if a directory already exists where it's gonna clone to, it would fail because it would not be able to create that directory that already exists. So to make sure we're not having that problem, because this, remember, this script will begin to run many times, we can check if that directory already exists. Okay, cool. So then we're gonna do is let's put some echo information just to tell us what is happening. Echo about to download 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 code base, something like that. And then I'm gonna show you a little secret. So there's a way to check. Um, so what we can do is we can attempt to remove the directory just in case it's there. You can do an rm minus fr and then fruits machine. So just remove it just in case it's there, and that's totally fine. Okay, but if it wasn't there, if you try to remove it, well, this script will run many times. The script will fail again. I would cause an error, echo question mark, echo dollar sign question mark. Okay. All right. So we can put that there just to make sure that it just deletes the file if it's there. So we can do so that this will never fail. So we can do let's just do the remover rm minus fr, which is remove the directory, which is this one, just in case it's there. Okay. And then if this is successful, we can just say okay, let's not make it too complicated. So then we can run this now. Okay, about to download code base. Let's run it one more time. Okay, you can see now this is working consistently because it cleans up before it does anything. Okay, right? So now when we copy the file, so the file remains in fruit, whatever, then ls. So we then have to go in the web file, web, we have an index file there. Yeah. So all we need to do then is basically we'll then do sudo copy. We need to copy this file, which is in web index. Index. Okay, sudo cp. So sudo cp web index. This is the file. The file is going to go into usr share nginx. Nginx HTML index. So this is where it's coming. So we're going to override this index file, and that's what we need to do. I'm not going to do it just yet, so that when we do with code, we're going to see it happen. So this is the what we need to harvest. Copy. And then papa, and then we'll do vim we can ls rather. So we go to the install script again. Okay, and then we're then gonna put that here. So it's gonna be sudo that copies it, and then that's it. And this system should be ready to go. So remember, this is a throwaway system we're using to build all our scripts up. So we're just gonna execute it again. Okay, no such file because we didn't seed into the location. So what do I mean? So with do vim, we should have done something like cd to fruit and veg directory which was created. It is in that directory we have the web file, whatever. or we can make it basically reference that here, but either way. And then we can also, if it's successful, let's echo it, echo file successfully, copied, something like that. Okay, let's run it then. Successfully copied. You can even do a car to test. Car, localhost, we know what to expect. You can see that this is what we expect. Okay, all right. In this file, we expect to find something like vegetables, right? So we can do a curl to check it, and then we can even grep for vegetables. Grep for vegetables or veg, something like that. Whatever we know we're going to find, okay, like vegetables. So that tells us vegetables. It's there. You can see that it's there. So we know this is working. Because if we grep and that page does not load something like vegetable, we know it hasn't worked. So if we do a grep and we get vegetables, okay, then we know it's good. Okay. And the way to do that is anytime you run a grep and the grep is successful, you can do what we call echoed last. You can check if this command is successful, the echoed grep vegetable, you can do $sign question mark, and that will come as a 0. What that means is the last command was successful. Let's say I did a grep for color, because it won't find color. If I check what the last command result was, it will be a 1. That means it wasn't successful. So if I can do something like this, I can so grep for vegetables, and so grep for vegetables. If that is successful, that's what this is mean. Just this mean. If that is successful, echo happy days, something like that. So this will only execute, this part will only execute if it's able to find vegetables in the localhost, whatever. So you can see happy days. And I can say echo and grep quietly. I don't want any noise. Grep minus, what's that again? Minus Q, quiet. And then we just quietly grep happy days. So if I say grep for color, there was not going to be a happy, well, color is always good. It's always a happy day, but you get the gist. So it's going to be color and no. So if you know that's gonna, so if it finds color, if it doesn't find color, they won't. If it doesn't find color, it won't be happy day. Yeah, without color, it's not a happy day. So if you want, so if it finds color, I will say if it finds color, it's gonna be happy days. If it doesn't find color, say where is color? Echo. This is how you write scripts. You can see it's very simple. Where is color? If you're looking at this like, if you didn't write it with this way, it may you'd be like, oh, what's going on here? But you can see how easy it is. So this will echo if color is found, and this or so if this happens, yes, and then do this. If that doesn't, if this is not true, it would say where is color. So that's the idea. You can see where is color. It's going to be the verdict. So this is just helping us to prepare. So instead of doing color, so we echoing vegetables. So we're gonna go into the script vein. Most of this thing I'm gonna throw away. I'm just kind of showing us how you write a script. So we're looking for vegetables. So in there, we're gonna say installation successful. That's gonna be installation failed. Installation. Oh, geez. Installation failed. That's what it's gonna be, but we are not looking for color. We're gonna be looking for vegetables. Vegetables. The only thing we might need to do, all this, most of this thing I won't put in the code. I'm just kind of showing us. So the only thing we might do is when we do the copy, we might let the system rest for a bit so that the copy of the updating of Nginx and what have you might take a little bit. So we can just sleep for 2 seconds or 3 seconds before we try to check if the installation is copy successful. Not that the copies, but it might take a while for the Nginx to register it. So let's sleep for 3 seconds. Just give the system some breather to actually ingest the file, and then we then do the grep. So if we then run that, and then oh, sleeping, boom. So this is how you write a script. Okay, so we know what we're gonna do. We know this works now, and we're doing on a throwaway system. So we basically use this, and we would use the pipeline to prepare this essentially. So we are going to target. We're going to target the. No, we are using it as a sort of the throwaway machine to prepare. We're going to target the work node, right, to do that stuff. So let's use a pipeline for it. The first thing is the pipeline needs to be able to access the work node, right? So we go pipeline. We go here. We'll say new item. We do web node setup. Okay, we'll take that. We're gonna start small, one step at a time. Okay, we're gonna prepare the pipeline as usual. Okay, people asking questions. Sorry. Okay, all right. Do we need to? Okay, yeah. Sorry, no questions. I hope this is interesting so far. Anyway, so we're gonna prepare our pipeline. We're gonna start sort of super easy. We know we want to hack those commands into our pipeline, but we're going to start with the simplest sort of form, something we're used to before we bring in things we probably are not used to. So we're going to do our pipeline as usual. So remember, I'm just kind of reading the script. We're going to move away from script. We're going to use the pipeline file at some point. So, but let's just start easy now. Agent any. Okay. We're not going to do any kind of strange thing here yet for now. So we're going to do stages as usual. Naturally, this will change as we go along. We're going to do stage. Just call this stage. Let's just call it test SSH. So we want to see if we are able to connect to if we're able to connect to the web node first. Let's test that. Because if we cannot authenticate to the web node, we can't really do anything. So steps is this. So we're gonna basically try to SSH the system. So we're gonna prepare what we call as SSH agent, which will allow us to connect to the system. So this is where we then do some magic here. Let's just say for now, we just say sh echo do something. Steps that just say echo do something. So when you use that, should be that, and then the thing should, so the one that starts should be the one that ends, and every other thing should exist in between. So it's a very simple pipeline, nothing fancy yet. Let's just get this working. This is the simplest pipeline that we can ever write. So let's just test this out first. Just kick the tires. This hopefully should just run without any hitch. We've not done anything at all. It's just the most simple pipeline you can ever write. It's not doing anything. Okay, do something. Okay. Now the next thing is we need to target this machine. Okay, we need to target this web node. We have the IP address. We can use a private IP, public IP, doesn't matter because running on the Jenkins machine, they're in the same network, so you should be able to access it in private. So probably we won't be inclined to use a private IP address. So we need to target this machine and we need to try to connect to it. I did mention yesterday, if you want to do machine-to-machine communication, you need a key to open the machine. So if you look at this, for example, we talked about this yesterday. It has my key, my case, I'm using the master key, master class key. If I can find it. Master. Okay, that's the key name. Anyway, so this is it here. That's the key name. But the key name is not important. The actual key itself, you should have that on your system when you created this key the first time. So machine-to-machine communication. So we want to connect. So this guy can provision the machine. Doesn't mean he can connect to it. So he can set them up, but he's going to need a key to connect to it and do all this little bit of install this, install that. Without a key, you can't get to it. There are many ways machines can communicate with them. So they can use private key, which is the easiest way, and they can use public key, which means, it's a bit advanced. We can look at it at some point. It will mean this machine needs to have its public key in the authorized file of this machine. So this guy will create, instead of having the private key of this one, instead of this, to have the private key of this will send its public key to this. And this will keep the public key of this. The public will be kept here in a file called authorized keys, and that will allow this guy to come into the system. So there are more than one ways to authenticate into the machine, but we're going to go with the simplest way, which is use private key. It's dangerous, but it's by far the easiest way. But the only thing is you have to have the private key of this machine. Thankfully, we do. So we're going to get the private key, and then we're going to attempt it. So I've got my key. Let's see. So I have the key on my machine. So this is my machine. Okay. And the key is in my download file. In my download directory is called master class 2025. That's the key there. Okay, so I'm going to copy this key without the percentage. It's very important. You are most careful when you're copying this file, because if you copy it the wrong way, it would take you hours to figure out what the issue is. So the most important thing is to carefully copy it, which I'm not doing now. So I'm going to be careful. Copy without a percentage up to that last dash for excluding the percentage. I know extracting on top is literally from this to the last dash there. Copy. So I have the file, right? I'm going to demonstrate what we intend to do with our pipeline. So imagine I am on the imagine I'm on the tool server, which is this one. So I want to target the web node. So let's say, for example, I want to target this throwaway machine. On this throwaway machine now, we are executing on this throwaway machine. Where's the throwaway machine? Throwaway machine is here. This is the throwaway machine. Yeah, this is the throwaway machine. The throwaway machine is here, right? So now we want to remotely target a machine because all these machines are using the same key. So if I have that key, I can connect to any machine in my case. So what I want to show us is how to remotely do something on a machine from a machine to another machine. So in this case, I want to just, if we go back to our diagram, I'm going to be on this machine, which is where the Jenkins is running. The Jenkins is running on this machine, the master key. The master server, the tool server is where the Jenkins is running. I need to get the master key on this machine. At a point, I'm going to use Jenkins to automate connecting to the web machine. But for now, I am going to jump on the machine and then put the master key there and then show you how the tool server will communicate with the web server using the master key manually first. So we go here, we get the Jenkins machine, which is a tool server. We probably will change the name later to tool server. So we connect to it. So we want to demonstrate how to connect our machines would. So that's the one there. Close this. This is custom. So this is the tool server. It's coming up. Okay. Okay, I'm going to the file, the key file I have, I'm going to copy it. I'm going to just vim master class dot hem file. That's going to be the one here. Copy here, paste. Oh, and I'm going to save it. Okay. I told you yesterday, if you click this file, you need to change mode to 400. I explained this yesterday. You can look at yesterday video to see why we do that. Change mode 400 master class dot span. Now with this file ready now, I can from here I can attempt to connect to. So I'm on here now. I can connect to the web node. Web node has nothing. So this is the web node, right? I can connect to the web node. So let me connect manually first. And let's confirm that web node does not have much going for it. So this web node, for example, if I say, show me a file called temp Mumi, the file does not exist. Okay, we know that file does not exist. But from the remote machine, which is another machine entirely, which is our test machine, sorry, with the tool set from the tool server, we can attempt to connect to this, create a file called Mumi on this machine, on a different machine. So we are here. We want to remotely create a file called Mumi on this machine remotely. So the way to do it is, let me get the private, let me get the throwaway, which is the one, this is the target system we want to create Mumi. So we get the private IP address. Okay, we know we don't have to use public, they are in the same compound and the same network, so they can use their own names. So we're going to go on the Jenkins or the tool server, which is this one. And we're going to tell it to access this machine and create temp Mumi on it. So we're going to say SSH minus I. So we're going to specify the file is the master key file. That's the file it's going to use to open it. And then it should open it as EC2 user at that machine. And then it should just touch, create a file, touch temp Mumi. That's how it's going to be. So we are saying connect to this machine and create a file called temp Mumi. So let's see. There's one thing I want to add. I don't want it to make a noise. I'm going to say don't check if, so there's always a check it does. Let me run it so you will see what I mean. So it's going to ask, I haven't seen this machine before. Are you sure you want to trust this machine? This is a problem if you're doing automation because the system will lock if it's connecting to another system for the first time. It's going to say, I don't know this machine. Are you sure that you want me to connect to this machine? You don't want that sort of noise or that impediment. You can tell it to not do strict host checking. You can just say SSH minus option. Don't do strict host key, strict host key checking. What this means is that it will not tell you, I don't know this machine, I don't know it from Adam. It will not just do that check. So we're just going to basically ignore that and move. You can see it's done the work. So if I go here now, if I say, you see, the Mumi now exists. But this is our system will communicate. They have to use the key, and with that key, they can open the system up and do what they have to do. And that's the same thing we're going to do using Jenkins. But there's going to be a bit of a twist to it. So on the Jenkins machine, because we're not going to be doing things on the console, we're going to be writing Jenkins pipeline, which is this pipeline. The theory is still the same, right? So the theory is going to be like this, but we're going to have to add some extra things. So what we want to do, we're going to do something like, we will do something like this. So let's say let's assume that maybe on that machine, we want to do something like sudo yum install install git -y. It's something we want to do, right? -y. This is something we want to do, but if we do this, it's not going to work because this is going to be we are still on the tool server. We need to be able to connect to that remote machine and do what we have to do. We can cheat and do the access the host key file on the machine and basically replicate what we've done on the console here, replicate it in the pipeline, but that's not a good approach. The best approach is to use what we call SSH agent. So SSH agent, you can keep your key in Jenkins, SSH key, and then reference it. Okay. And that would be the best approach. What do I mean? So let me just save this and take this away for now. So what we do is you go in Jenkins, two things we need to do. For us to be able to do remote SSHing and executing stuff, the first thing you have to do is you have to install SSH agent. So you go here, just make sure you have it. You go to where is it? You go to plugins, yeah. So I'm looking for plugins, and then you say you can go to available plugins, and then you search for SSH agent. So you can SSH agent. Let me see. I think I may have installed it. Let me see. SSH agent. Now this is the one you need. SSH agent plugin. I already have it. You can see, but you may not have it. It is important you have it. If you don't have it, just install it. Just say available, or you can just search SSH. I think for me, it will not be available because I think I already have it. So in your case, it should be there, but that's the one you need to install. SSH agent is already installed in my case. So you have to install that SSH. You can see SSH agent plugin. So you need to install that, and you might need to restart your Jenkins machine, etc. So that's the first thing you need to do. The next thing you need to do is you need to go in Jenkins, okay, and you will go to manage Jenkins again. You will go to credentials. And what we want to do here is we want to bring in the key. That's key. This key, we need to bring it into Jenkins. Okay, just here. So you go credentials, you go Jenkins, you go system. You then click on credentials. Then say add credentials. The kind of credential we want to add is the SSH credential. So you click on here and say SSH username with private key. That's in order. Just say SSH username with private key. Select that option and then give it a name. You can say AWS SSH key, something like that. AWS SSH key, something like that. And then username, we're going to use this EC2 user. Remember, that's how we connect. I'll just leave it at that. But what is the most important thing is the key. So enter it directly here and then say add. This is where you dump the key and you have to carefully copy this. Otherwise, this might slow you down if you don't do it correctly. Before you figure out what the problem is, it would take ages. So it is very important. You don't copy if you copy like this, you're in trouble. You have to copy up just literally where it starts and where it stops. I don't even think I'm doing it well now. So, but I will see. So, but just be careful. That's one thing that will slow you down. I'm kind of telling you ahead now when you start your assignment. Okay, right. There's no passphrase. It's just that EC2 user key, blah. Remember, we're going to reference this and EC2-user, and then you create it. And that's it. So with that, now we can reference AWS SSH key here. So what we then do here is we then say, okay, we're going to use a plugin called SSH agent. So we say SSH agent is what we're going to use. Okay. And then we're going to use credentials. We're going to look up the credentials. Okay. And then the credentials we are using is the one called this, right? And then within that, we're going to do some magic. We're going to use echo and do some SSHing. So we're going to do a number of commands, okay? So we want to do like SSH, we'll do that. So this is not needed anymore. So we do that. So what I'm doing here is I want to tell the system I want to put a lot of commands. So the command I'm going to put is going to be here. So I would say SSH, literally what we have here. What is it? Okay. So which what we did here. So we're not going to need this because it's already Jenkins will automatically access it because we're giving it the file. So what we need to do is just the other bit, which is without the master file, whatever. We don't need that. So let's just copy this. So probably will not do one. We probably might do Cynthia. Yeah. So right, let's do this one. So let's search here. So we're just gonna do that. So we don't need this because that's implicitly referenced here. We're gonna get that out. And then that's the machine. And then we're gonna do something like that. So if this goes well, that should access the system for us. Okay. Now let's apply and let's test it out. Apply, test it out. If this works well, then you should be able to connect to that system. Okay, looks good. I suppose. Let's not even check. Let's be confident. Let's go ls Cynthia here. Here, voila. You know, there's no git here. Okay, just guess what? You can come here, configure, and then you can just sudo yum install git -y, something like that. Right, save, build, and Bob should be your uncle. Da, 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 da. Da, 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 da. Okay, you can see that. Beautiful. So if you then go here, let me say, where is it? Here. There was no git before. They just gave version. Absolutely beautiful. So you get a JSON. So we do have this file on the throwaway machine, which we were preparing our little script. He's still alive. He may be dead now. Yeah, okay, it's dead. The throwaway machine, I think I remember the command. I don't want to waste too much time. So what we're gonna do, yeah, it's very easy. So we will install Git, we will use that Git to kind of, download stuff, etc. So I'm just gonna string the commands together. You're gonna have to forgive me because of time. We're gonna run out of 5 minutes, if you don't mind. So what I would do here is I'm gonna do something like this. So we go here, configure. So I'm gonna do yum install git when I get this there, and then I'm gonna spring it again. I could do like a semicolon. It's not great, but let's do that. And I'm gonna do git clone or cd home, and then git clone that. I should have been using semicolon, but let's see if we can get away with it. Otherwise, I'm gonna change it. So this is the one we wanted to clone. We use SSH, we use that one. And then we'll bring it here. Okay. And then let's CD to fruits market. Let's test that out. Apply, save, let's see, build. Okay, everything is good because if we go on this machine now, which is our tool set, which is the web node, and that's one as RTL, guess what? It is there. Obviously, if we run this again, it's gonna fail because it will say the directory already exists. So we might have to do something very, it'll be convenient to just do a removal. So before you clone, just do rm-fr and then fruit and veg, just in case it's there. And that's it. Okay, and then we can do everything. We can also yum install Nginx here. Before we do, let's do Nginx. Nginx. And Nginx -1. And then we can sudo service or systemctl. You can use that systemctl start nginx semicolon, and then we'll do the fruits and veg, and then we'll see the two fruits and veg. So you can see it's getting long. So let's see where this takes us. I think it's a semicolon here. Okay, I'm kind of using the crude approach, but I want us to kind of follow it. So I don't want to just dump the script on us and say, how did you get that? So if we fail, we're gonna see why we fail. And that's the whole point of doing live classes. So that goes, and it's going. Let's look at it. It's all like super quick. It's done. It's done. Boom, boom, boom. It's done. Okay. And that should have gotten us to the point where we have Nginx of the sudo service or systemctl system ctl Nginx status. This is status Nginx. I think it's status Nginx. You can see it's there. But now, if we go here and we get this web node, we won't get our file yet because it's here. All right, if we go here and we do HTTP in front, HTTP, nothing happens. It's just going to be that default blah, 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 blah. Until we basically say in the pipeline, just basically say in the pipeline that configure. So after this, we want to cd to fruits and veg, and then we'll basically do sudo copy. Let me just make sure I do it here. So I'm not going to do it here, but I want to make sure I get the command right. So we know the fruits and veg is here. So we cd to fruits and veg. Cd fruits and veg. And then we do a cp of web, okay, index file. Actually, we do a sudo cp because the directory we are going, we don't have, normally we don't have access to it. We do sudo command. We're going to usr. We're going to share. We're going to nginx. We're going into HTML. And then the file is the index file here. So that's where it's going. So this is literally the command we need. And then that changes everything. So we go here. Override that. And then Bob should be our uncle, sudo blah, 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 blah. And this is what would change it from humble welcome to something brilliant. Of course, when this runs, of course, you know, all those Python, whatever will be broken, right? So, but we expect this to change. Where it will be a broken system. Okay, so we apply, we save, and then build. Okay, you can see that. It's successful. So if we refresh this now without even going there blindly, we're confident it should change. See that? It's changed, and this is where we're gonna stop. So so what I want us to do is leverage this pipeline, of course. So but this pipeline should probably not exist here. So I was having something different in mind for us to do, but because there's no time, so we're probably just going to limit ourselves to garnishing up this web machine only. I was hoping we'll get to the Python side, but it's fine. So we obviously won't get to that now. So what I want us to do though for the project, this week's project, is to look at this, configure. Everything is sort of sandwiched here. So we can divide this into two parts, okay? We can have we can have the instead of test SSH, we can say prepare system, which will be the installation of Git, whatever, blah, blah, blah. And then there's the deployment. This is the installation part. The deployment part will be the copying of the file to that location. That will be deployment. And then we can then have it as maybe node, let me say, let's say install install packages. So install packages probably should only have all these install. This other bit, which is the CD blah blah blah, that should be in another pipeline. It's in another stage, which would be deploy code. And that's where you will basically do the CD and stuff. The reason I'm saying this is you can then divide your work into, you can select, because it's not every time you're going to be installing. Sometimes you will install as a one-off, but you will deploy many times. So you have the install stage and the deployment stage. So that's the same thing we have with Terraform. Can they have this install part? You can select what you need when you do params to install and params to deploy. Okay, that will be one. The other thing is we would not use this file here. Now this file should be part of this entourage here. So you have a Jenkins file. So you can say Jenkins web, Jenkins Python, Jenkins Java. That's the plan. So bring the file in here as a Jenkins file and just say Jenkins web and then reference that and then use that as part of your pipeline project. So when all is said and done, you should at least something like this. If you want to go as far as, manually setting up your Python and Java to have this populated, that's fine. Or at least use automation to get your web up to this point. If it doesn't populate, that's what we want. It's fine in as much as all automated. And I'm so sorry. This is where I am going to stop. Okay, I know we've used a lot of time. Any questions or comments? And thank you for obviously shouldering on to the beta end. Fantastic. So I will set up the project work as usual. I'm wishing you a blessed week, and the video will be shared as normal. Have a good one. God bless.